Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 2, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 5 part A says, by reference to direction of propagation of energy state, what is meant by a transverse wave? So first of all, imagine that transverse wave is moving to the right. So this is direction of propagation of wave and this is also direction of propagation of energy. Now we can imagine medium particle here. So how this medium particle will move? This medium particle simply will move up and down. So this is direction of vibrations of medium particle. So this is medium particle. An angle between these two is 90 degrees. So simply we can say direction of vibration of medium particles are perpendicular to direction of propagation of wave or direction of propagation of energy. And for longitudinal waves, if wave is moving to the right, so this is direction of propagation of energy. So the medium particle, they will move forward and backward. And this wave is longitudinal wave. So this is representing longitudinal wave. So simply we can say this is representing longitudinal wave. So angle in this case is they are parallel to each other. So simply you can say direction of vibrations of particles are parallel to wave direction. So this is how we can define longitudinal wave and transverse waves. Now let me show you the answer, how you can write down your answer. In your answer you can mention these points. You have to mention vibrations of the particles. You have to say perpendicular to direction of propagation of energy. So you will get 1 mark. Part B says a space telescope is designed to detect electromagnetic radiation with wavelengths in the range 12 micrometer to 28 micrometers. State the region of the electromagnetic spectrum. So simply you need to understand this range. For infrared, for example, so this is very important range. Infrared, they have wavelength between 10 to minus 4 to 10 to minus 6 meters, about this range. So you can see here we have micrometers. So because this is in meters, so this is micrometer. So it simply means that this is infrared. So simply you can say this is infrared. Part C says a detector on another space telescope detects an electromagnetic wave. The signal from the detector is transmitted to Earth and displayed on an oscilloscope as shown in figure 5.1. The frequency of the signal displayed on the oscilloscope is equal to the frequency of the detected electromagnetic wave. The time-based setting on the oscilloscope is 5.0 times 10 to minus 15 seconds per centimeter. It means 1 centimeter is representing 5.0 times 10 to minus 15 seconds. Calculate the wavelength of the detected electromagnetic wave. So we need to calculate wavelength. So first thing we need to understand, in this case we are talking about EM wave. So very important one. EM wave means electromagnetic wave, and all electromagnetic waves, they travel at speed of light in vacuum and also very close to speed of light in air. So simply from here we can say the speed of all electromagnetic waves is 3.0 times 10 to 8 meters per second in vacuum or in air. So we need to calculate lambda. So we understand V is equal to F times lambda. So F times lambda, or we can say this is lambda over time. So from here we can say lambda will be equal to V times T, means time taken, V times T. Time taken, this time taken, very important one now. This time taken has to be the time period because we are talking about one cycle. Distance traveled by the wave in one cycle. So this time has to be time period. So simply we can say this is C times T and this T is the time period. So if we have value of time period now, we can find out value of lambda, and value of C is 3.0 times 10 to 8 meters per second. So we just need value of time period. So how we can find value of time period? At this point we can take, it's more convenient, and we can take this point here. Actually this point, and it has to be this point here, somewhere here, this point you can see. You can take this point, you can take this point, or you can take this point, or you can take this point. So this is representing one complete cycle. So if I take this one, so this is easy to see, so let me draw this wave so you can see. This is representing one complete cycle. So this is one complete cycle. So how many small square we have? We have 1, we have 2, 3, 4, 5, and 6. So we have 6 small square, and one small square, we can say one small square in this case. So we can say one small square. One small square is 1 centimeter. So we can say one small square in this case is 5.0 times 10 to minus 15 seconds. So one small square is representing this. How many small square we have? 6. So the time period will be equal to 6 times 5.0 times 10 to minus 15 seconds. So you have to be careful with this unit. This is second. Now if we multiply this one, we will get over final answer. So in this case, final answer will be equal to 9.0 times 10 to minus 6 meters. So this is the wavelength. So this is also, you can see this is infrared because it is in micro. So this is our final answer. We can also write down here. So this is 9.0 times 10 to minus 6. As given data has 2 SF, so our final answer also should have 2 SF. Question 6 part A says coherent visible light of a single frequency is incident on a double slit. This produces a pattern of bright and dark interference fringes on a screen as illustrated in figure 6.1. There are 7 bright fringes. For part 1, explain how the pattern of bright and dark interference fringes is formed. Mean how these bright and dark fringes are formed. In order to answer this question, first thing we need to understand waves at this point, they are in phase. So we can simply say waves here, they are in phase. Now first of all, we will look at the bright fringe, how this bright fringe is formed. This bright fringe is formed if the waves at this point on the screen, means at this point on the screen, if they are again in phase, so we will see a super wave, super crest like this. So this is due to constructive interference, and when the waves they meet on the screen, if they are in phase, they will form bright fringes. So this is when they are in phase. So simply we can say bright fringes are formed when the waves are in phase. And now if you look at dark fringes, I'll be just looking at this fringe. Dark fringe is formed when the waves they reach the screen, means they reach this point, but they are anti-phase 180 degree. If the phase difference between them is 180 degrees, they will cancel each other, so we will see no light. So this is when they are anti-phase on the screen. So we can say anti-phase on the screen. So these are the points you need to understand to answer this question. Anti-phase also means that angle between them, phase difference, is 180 degrees, and in phase means that phase difference between the waves when they meet on the screen is equal to 0 degree. On the screen when they meet, if the phase difference is 0 degrees, it means constructive interference, and we will see bright fringe. And if the phase difference is 180 degrees, it means that is destructive interference, and on the screen we will see dark fringe, means no light. So you can see the beauty of that. Light can cancel. So it doesn't mean that if you have light always you will get something bright. So light can also cancel light. Something different from our everyday observations and from our everyday way of thinking. Means the normal way of thinking, not thinking as a physicist. So this is something very important one. Now let me show you the answer, how you can write down the answer. In the answer you can mention these points. You can simply say light diffracts at the 2 slits. Here light will diffract. So this is telling you the light will diffract here. Light from each slit superposes at the screen means the waves from the slit, they will meet at the screen. If the phase difference is 0 degrees, we will see a bright fringe, and if the phase difference is 180 degrees, we will see a dark fringe. So this is how you can answer. It's a nice question. You need to understand how bright and dark fringes are formed, because this is a typical question in the exam. Second part says the distance between the centers of bright fringe X and bright fringe Y in the pattern is 10.2 millimeters. The slit spacing is 1.2 millimeters. The distance from the slits to the screen is 3.1 meters. Calculate the wavelength of the light incident on the slits. This is typical question, but little bit tricky one. So how we can answer? In order to answer this question, simply we need to understand that AX, this is equal to lambda times capital T, and we need to find lambda. So lambda simply will be equal to AX divided by capital D. So we need to understand what is A. A is slit separation. Slit separation means that the distance between centers of slits. So simply we can say A is distance between centers of slits. Centers of slits. Center to center distance. So you can see here. So this is over value of A. We also call this is slit spacing. So this is slit spacing. So you need to understand these terms. Very important. Slit spacing. What is X? X is fringe spacing. Fringe spacing, but this is not complete answer. Fringe spacing, often confusing this one, so we need to understand this one a little bit in detail. What is meant by fringe spacing? So this is the distance between centers of, we can say distance between centers of two consecutive bright fringes. Consecutive. If you got this point, you will not make mistake. Distance between centers, so I'm writing here between centers of two consecutive bright fringes. So this is how you need to understand two bright fringes. But what is this distance? This is not X. This distance is not X, and this distance between slit and screen, we call this is capital T. So here we have value of A, that is 1.2 millimeters. So this is 1.2 millimeters, but value of X we need to find out. Value of D we have, that is 3.1 meters. So you have to be careful with units. Now the question is how we can find X. So we need to look at this one. So you see we have bright fringe here, we have another bright fringe here. So we have 1 here, then we have 2, then we have this one 3, this one we have 4, this one we have 5, and this one we have 6. So this is 1, and here I can say this is 2, this one is 3, this one is 4, this one is 5, this is 6. It means this distance, we can say this distance D, let's say this is equal to 6x. But we need to find out X. So X will be equal to D divided by 6. So it means 12.2 millimeters. This has to be divided by 6. So this is what you need to understand. Now let me use arrow here to make it more clear to you. So this is one arrow, you can see. So this is 1x, this is 2x. This one is 3x, and here we have 4x, and here we have 5x. So here we have 6x, and this is equal to D. So it simply means that simply we need to write down x is equal to 10.2 times 10 to minus 3 divided by 6. Now if we solve this one, we will get lambda is equal to 6.6 times 10 to minus 7 meters. So this is value of lambda. Our answer should be up to 2SF, because the given data you can see it as 2SF. This one has 3SF. This one has 2SF. So in the final answer, you have to use the least number of SF in given data. Answer. So we can simply say answer. Number of SF are simply, let me write on here, number of SF in answer should be equal to least number of SF in given data. So this is the rule we follow, but you can use one more that is also acceptable. Given data or one more, we can use or one more. So this is how we need to answer. Question says the light is replaced by different visible light with a shorter wavelength. State how the new fringe separation will compare to the original fringe separation. So we need to understand we are using the same double slit, and this distance we are also keeping the same. So if we change lambda, how this fringe separation will change? So simply we can write down x, this is equal to lambda times capital D divided by A. We are keeping A same, we are keeping D same. So if lambda decrease, it means x will decrease. It means that fringes will be closer than before. So the fringe separation will decrease and fringes will be closer to each other. So this is simply we need to write down. We can say new fringe separation will be smaller. So we can say new fringe separation will be smaller, or you can say fringes will be closer. New fringe separation will be smaller than before, will be smaller than before. So this is how we can answer. Part B says a stationary wave is formed on a stretched string AB as shown in figure 6.2. P, Q and R are points on the string. For part 1 on figure 6.2, draw a cross to show the position of a node. So the best way to answer this one, first of all, we can complete the waveform of the stationary wave. So this is how you can complete it. It will look like this. Not very good looking, but at least you can get the idea. So this is how it will look like. Now if you look at this point is the node. So this point is node, means particle at this point has zero displacement, and particle at this point also will have zero displacement. So simply you can label this point x, or you can label this point x, even you can label this one x. So any point if you label, that is the node. So these are nodes. So if you want to write n here, you can write down, you can also write down here. So this is how you need to answer part 1. For the second part, we need to state the phase difference between P and Q, and you can see P and Q, they are between two consecutive nodes. So all particles, they have the same phase, means they have zero phase difference. So they have the same phase. At any given time, they will be moving in the same direction. So they have zero phase difference, or we can say they are in phase. So between this, all the particles between these two nodes, they are in phase. And also particles here, they are also in phase. But these particles, they are moving up. Let's say this particle is here, so particle in this loop at this point will be moving up. Particle here, it will be moving up, and particle here will be moving up. And you can see particle here, for example, here they will be moving up. If we have particle here, this will be moving up. If we have particle here, this will be moving up. So the main point is all the particles between two consecutive nodes, they have zero phase difference. So simply we can write on here zero phase difference. State the phase difference between P and R, mean this point and this point, and the phase difference between them is 180 degrees. Means when this particle is here at the lowest point, this particle will be at the highest point, and vice versa is also true. They will be moving like this. So these are some very important points you need to understand about stationary waves. These are basic points, so you have to be very clear. And also you need to understand this particle, for example, and this particle, they do not have the same amplitude. The amplitude is different. All the particles means in this loop, they have different amplitude. So let me write down here. They have different amplitude, but they are in phase. So they have different amplitudes, but in phase. So these are the points you need to understand between here and here. Then same is true between these two nodes. Same is true between these two nodes. So this one is true for each loop. So we can say for any loop, you can say for any low. This is true for all. And that's all for this video. We will just stop this video here. We left only 2 questions, and those questions are very short questions. One is about electricity, one is about radioactivity, and I'll be uploading those 2 questions later by today. And if this video was helpful, please like and subscribe, because your encouragement is very important. And also, if you're looking for extra resources, you can check Patreon. And if you have any questions, please leave your questions in comments, and I will try to answer as soon as possible. And if possible, please share with your friends, so your friends can also get benefit from these videos. And also request them to like and subscribe. See you in next video.